students. In the last class we have seen the limitations of the octet rule and bond parameters. So in the limitations of the octet rule, three limitations that is very important. Okay. Then in the bond parameters we have seen bond enthalpy, bond order, bond angle and bond length. Okay. For the stability of the molecules, bond length should be smaller and bond enthalpy and bond order should be higher. Then the molecule is very stable. In the diatomic molecules, N2, nitrogen molecule is highly stable because its bond order is 3 and bond enthalpy is 946 kilojoule per mole. That value is highest in the diatomic molecules. Then in isoelectronic molecules are the ions, that is having same number of electrons. In such molecules, bond order is same. Okay. Today we will see resonance. So now you know how to write the Lewis structures for different molecules, right? Single Lewis structure could not explain all the properties of the molecule. Single Lewis structure could not explain all the properties. Explain all the properties of molecule. It means what? That is, molecule has different structures. Molecule has different structure. Single Lewis structure could not explain all the property of a molecule, indicating molecule has different forms or different structures. For example, we will see ozone. So this is the structure of the ozone molecule. O3. Ozone structure, if we see, this is the ozone structure, 3 oxygen molecules. Here, this 2 oxygen is bonded by the double bond, oxygen to oxygen double bond, and this oxygen to oxygen single bond. So while writing this structure, I said this double bond can be here or it can be the other way. It can be like this, right? So here there are 2 different structures for the ozone. Let us name this as a structure 1 and this is the structure 2. Okay. So in this ozone molecule, oxygen to oxygen double bond. Oxygen to oxygen double bond, bond length is 121 picometer. Okay. Whereas oxygen to oxygen single bond length is 148. So single bond length is 148 picometer. So here oxygen to oxygen single bond length, second structure 148 picometer. Here 121 picometer. Okay. But when ozone molecule was synthesized, experimentally when bond length was determined, the experimental value of bond length in ozone molecule was 128 that is 128 picometer. Okay, theoretically, you know, when molecule forms, if it is having oxygen to oxygen single bond length will be 148 picometer. If oxygen to oxygen double bond length forms, then double bond length is 121 picometer. When we write the Lewis dot structure for the ozone molecule, we will get two Lewis dot structures having one single bond and one double bond. Then when ozone molecule is synthesized, we should get two bond length. When we calculate the bond length, experimental value, we should get two different bond length. But it was only one bond length was 128 picometer. Two oxygen to oxygen bond length were same, 128 picometer. Now this value 128 picometer is in between 121 and 148 picometer. It is in between 120 picometer. So the bond in the ozone molecule is intermediate between single bond and the double bond. So the bond in ozone molecule is intermediate between single bond and double bond. Right? See the structure. The third structure. Now this is third structure. The bond is one single bond. I have written solid line and here dashed line. The second bond I have mentioned represented in a dashed line. This indicates the bond is in between single bond and the double bond. It is neither a single bond nor a double bond, but in between single bond and the double bond. So because of this reason, the resonance concept was introduced. Okay? Single Lewis structure could not explain all the properties of the molecule. Therefore, resonance structure was introduced. What is resonance? Definition of the resonance. The properties of a molecule. The properties of a molecule can be explained by representing structure in different forms, which have nearly similar energy, positions of nuclei, and number of bonding and non-bonding electrons. Resonance definition. The properties of a molecule can be explained by representing structure in different forms, which have these different forms of the structure have nearly similar energy, positions of the nuclei is similar, and the number of bonding and non-bonding electron is similar. Look at the ozone structure, first and the second. Both the structure have similar energy. The positions of the nuclei is same, and number of bonding and non-bonding electron. Look at the structure. It is having only double bond has 2 lone pair. Look at that second structure, there is 2 lone pair. Where also in single bond, there are 3 lone pairs of electron. Here also 3 lone pairs of electron. Now these 2 structures are called as resonance structure or canonical structure resonance structures or canonical structures. So in the ozone, first and second structures are the resonance structure. Resonance is indicated by double-headed arrow. Resonance is indicated by the double-headed arrow. Okay, so there is double-headed arrow. And this third structure, this is the hybrid of these two. That is called as resonance hybrid. Resonance hybrid. This structure is called as the resonance hybrid structure. Okay. So this resonance hybrid, it will average the characteristic of the molecule. Resonance hybrid will explain all the characteristics of the molecule will be averaged by the resonance hybrid structure. Okay. In the resonance hybrid, it is having less energy. Resonance hybrid is having less energy compared to resonance structures. Resonance hybrid is having less energy. Therefore, resonance will give stability for the molecule. If molecule is having resonance structures, means that molecule will be stable because it is resonance hybrid will explain the properties of the molecule. Resonance hybrid is having less energy compared to this resonating structure or the canonical structure. Okay. Hope you understood resonance concept. Resonance means the property of the molecule is explained by representing structure in different forms. These different forms of the structure, it is having similar energy, positions of the nuclei and number of bonding and non-bonding electrons. When experimental value, the bond parameters will be different than theoretical value, while every structure is a theoretical representation of the molecule. Right? It will be having different values. When molecule was synthesized and studied, the value was in between these bonds. So the concept of resonance was introduced. Okay. Next we will see the carbon dioxide molecule structure in terms of resonance. CO2. Only for the ozone, resonance hybrid structure is given. Okay, that is given by 3 equal marks, right? Whereas CO2 and one more carbonate we have to study. For that, resonance hybrid structure is not given. Only resonance structure is given. Now CO2 molecule, if we see, it is having structure like this. We have studied structure like this. Okay. One more structure like this. picometer. Now this value is in between 121 and 110 picometer. What it indicates? Carbon dioxide, the bond length, it is not a double bond, not a triple bond. It is in between double bond and the triple bond. Their resonance structure, while writing resonance structure, we should show the double bond as well as the triple bond. So in first structure, this is the first structure, both the bonds were double bond. In the second structure, one bond was triple bond, the other was single bond. Second structure, okay. If triple bond is here, it can be here also. That is represented in the third structure. Okay. When carbon dioxide is synthesized and experimental bond length value was 150 picometer, the normal carbon to oxygen